All right. Well, thank you everybody for joining today's ELISA seminar on safety element out of the context concept driven into extreme. The speaker is Håkan. Håkan is a senior technical leader from Volvo Cars. We're very delighted to have Håkan to give us this very informative talk. And if you have any questions, comments, please save it toward the end. We'll leave about 15 minutes to answer your questions. You can type your questions in the Q&A window. If you have any quick comments or things you would like to say, you can definitely put in the chat. We can take a look as well as we go. With that, I'll pass the microphone to Håkan.
Yes, thank you very much. Hope you can hear me. Yeah, good. So good morning and good afternoon, depending on where you are. So happy to be here. Håkan Sivencrona as presented. I've been working quite a long time with standardization within EE systems for automotive industry. Started at Delphi 2005 actually, and has continued to work and look at how the safety element out of context concept has developed throughout the years. And now it's a new release of ISO 262 coming up, so I hope to be a little engaged in that as well. But without further ado, I would like to start. So let me see here. So what do I want to tell you during this presentation? Well, of course, a little of the background of SEooC, and especially in the light of ISO 262, which is the standard where it belongs. And I would certainly dig into what safety element out of context is. And also, if we can understand the principles behind it and in it, it can be hopefully very efficient for your company or you to use. And of course, I'd like to have the SEooC presented here in the continuous integration, continuous deployment, and in a DevOps, because that makes most sense. But we will come back to that later on. So let's start. So my goal is really to give you the safety element out of context in the light of ISO 262 reference life cycle. This safety life cycle takes care of everything from you do your item definition, you have your function, and you do your hazard analysis and risk assessment, and you break it down and you verify and you validate, and you have the supporting processes in place, right? So that's the life cycle we are looking into. And I like also to present some of the concepts that are needed around the safety element of context. I will compare it to some other concept that I see has been misused or misunderstood in the standard. So I will touch this a little. And also we will see it in the light of CEICD, as I said previously. And the fifth, and we can see safety element out of context as a pattern, so it can be applied to all components basically in a system design. And we'll talk a little about that in the light of an ADAS or 80 for that thing. It's just exampled. So a little about the agenda then, introduction down to why it's needed, etc., etc. But keep in mind that item, that is the function here in this presentation, HARA, that goes into a functional safety concept, that goes into a technical safety concept, that breaks down in software safety requirements. So this is something to keep in mind when I speak about these words, that you know that they are an abstraction of or a breakdown into several aggregations. So, and you see the life cycle behind. So the background for myself, I mentioned it, I worked for Mikkel Delphi. Mikkel was a software company owned by Delphi and really made a lot of stuff for Delphi to begin with. They made the first version of AutoSAR software stack that would be useful for many purposes. And that's when I really saw that some came with the requirements, please provide us with an ASIL-A. And we would like to have ASIL-B AutoSAR. And sometimes it's misunderstanding what an ASIL is, and sometimes it was misunderstanding of what you actually can require from something that is developed already before they came to you, right? But sometimes it was really a misunderstanding of what is an ASIL-B. So they thought that it's just process argumentation and nothing more, and that we would like to change with this presentation. And also similarly, I worked quite a few years with the active safety of Delphi. So and they sold radars hardware with including, you know, mobile eye cameras and the sensor fusion to several OEMs. And here we really needed to be able to maintain our product, have this core or safety element out of context really in close control so that we can sell it without doing too much redesign or heavy verification. But in the end, we would like to have a configurable and out of context argumentation that we can sell this with a minimum effort to as many as possible and still have the safety case. And when I proposed it for ISO 262, it took some time, but we were like 4 or 5 people that worked on this, and we had a good time doing it. And it was introduced in 2011, and then it continued to be in the 2018 version, and hopefully it will be also in the next releases. But as said, it can be developed, and we have learned a lot, and it has misused. So, introduction to the SEooC concept and the need. So first, I just wanted to mention a little about the DevOps, which is fundamental now for most of these agile companies that we see around, but the OEMs have started with it and the tiers as well. So we would like to be very fast and swift so that when we code, we can actually build it fast, we can test it, we can release it. And when we have deployed it, we would like to really get feedback from the cars, from the fleet. We monitor that and we can plan for new releases. And especially for AD and ADAS, this has come to really surface as an enabler, which we really need to look into, not spending too much time on it. But we also mentioned there that the DevOps emphasize on frequent code integration. What is frequent? Well, not too frequent. It's as frequent as your organization can carry, because sometimes it really takes time to really carry out or execute certain safety activities. So it means that fault injection or some other maintenance, or I mean, what should I say? If you would see if it's wear out something, you would like to have more than just a day. Maybe you will need weeks, you need maybe months before you can actually say that you have verified something. That's what I mean. But also, I think it's really important here that a really good DevOps, it promotes a culture where team can work together and share responsibilities and really help each other to maximize the use of it. So CI/CD, it's very often used, and you see this, but it stands for continuous integration, continuous deployment, and it's continuously evolve the product in frequent increments. And I think this is one of the good concept when you are having a SEooC, when you have a safety element out of context, that you can, in the actual usage, when you have sold your component, you can improve it fast if you have done it in a very good way, the safety element out of context. So going back to ISO 262 again, and it's usually starts with that we have an item, and it's traditionally it was an item we thought of ABS, for example. We could say electric power assisted steering and things like that. But it's really used for automotive E-systems where electrical faults or systematic faults or random hardware faults, software faults can actually make the function deviate. So we needed to have best practice how to avoid this from happening. But on the other hand, we didn't really care if the function itself was safe. If the ABS wasn't safe, we didn't really care. So of course, you can use the ISO 262 metrics and measures on a weapons, of course. But also, another thing that is really important to remember here with ISO 262, we also introduced controllability, which is a main difference from other standards such as IEC 61508. But we know that these requirements coming from hazard analysis and risk assessment will be safety goals that we need to achieve, and they are on the vehicle level. And this is a nice V90, and I love this car. Yes, so in the end, we would like to have no unreasonable risk, and you can see in the standard how this can be achieved, but we leave that for now. So just safety case to get us on the same page. I mean, we know that it's a comprehensive collection. Sometimes we say that it's a compilation, it's a collection etc., of all the work products and the argumentation. And some have been using the goal structure notation to do this. But basically, a safety plan that says this is what we are going to do to be able to claim that it's reasonably safe. And then there are hazard analysis to see what does that mean, safety mechanism, and then the evidence that this is good, etc. So we are fairly acquainted with that, I believe, if you're attending this presentation. I hope so, but otherwise you will see it in the recording, and you will also be able to have these slides distributed. So objectives from an ISO 262 perspective, if we have the OEM side, then of course this is everything circulates around the OEM side, right? And it's like the conductor having the orchestra with all the instruments or components, for that sake, to make them play together. That's the task of the OEM, and which is not so easy, right? Because if you do a function on the vehicle level, it's not that you would like to say, oh, it would be great if we needed a camera. Let's design a camera. We need to design an imager. Well, okay, we need to continue. Okay, of course, that's stupid just to continue the reasoning. But we understand that it's really tricky to do some good requirements as an OEM, and then just hope for the best that someone will take care of it and come with exactly the same answer that you want. But we see that we have a lot of dependencies, but that is the real responsibility of OEM, if of course, to integrate and to validate that it is safe. But if you look at the tire one side, tire two side, tier one, tier two, I mean, you see that, oh, here is a piece in the puzzle that is missing. The OEM, he really or she really wants to have my product here. I can make this wall perfect with my component, right? So we see that you have a sub function. You have something that you really think that the OEM can use, but you know quite a lot about it, but you don't know exactly how the OEM will use it in the end, right? So there is a lot of unknowns, but you can at least aim for it. You can assume that if we assume this, they will probably be happy and would like to procure my components, right? So this is the start for the reasoning here in the presentation. So, but again, ISO 262 written from a top-down approach. You have the top level requirements, and you go through the tier one, tier two, tier three. There's no one doing that, right? Maybe for the simplest functions, but let's say that we use ISO 262 lifecycle as a reference, right? But we also understand that the bigger the system comes, it becomes more and more complicated to maintain the traceability, to main verifications, and to see dependencies between certain components. So you need to have a very good approach to do it. And that's where we think the safety element out of context is fulfilling quite a few needs. So the safety element out of context principle has been known for a long time within many areas. So that is not any novelty really within it, but this picture is from ISO 262. So basically, if you are going to develop a component, you would like to say that these are the assumptions that we should use in order to sell our car. I mean, this is the need we think we can fulfill at an OEM. And you also think that if they have this and this and this and this, we can do something really good. So of course, it boils down that we have our own safety requirements, we have our design requirements, and we can do a design. And we know for sure that the suppliers in many areas know the functions, even on the top level, a lot better than many OEMs that are introducing something for the first time, right? Leaders versus followers. So it might be that some tier ones have been working for some OEMs that has had a function for 3-4 years in use, right? It's most likely that the tier one knows quite a lot that the OEM doesn't. So yes, but anyway, the tier one must assume a use case. That's the point, right? So let's continue. So I'm thinking, I mean, why should we then use the SEooC? Of course, that we see that the challenges are really growing and meeting suppliers and expansion challenges. What I mean is that we in traditional systems, we really had one system, then we can change it a little. I will come back to that. But for ADAS, we are constantly coming up with new features along with the new regulations and laws and things like that, especially within the EU, where we have new laws, we have new, and also Euro NCAP, they have their roadmap for how to be more and more safe to implement everything. But we also see that this complexity is really hard, and not the least now that we have AI. How should we work with AI? So also that we have that the methodologies used by OEMs have quite a lot been bound to use, these traditional systems like ABS. Well, we have a good functionality. Now let's make it safe. We can maybe adjust it a little. Yeah. But we see also that we need to have rapid changes, and it comes with a cost also to have these changes done in your system. So how much are you willing to pay, really? There is a lot coming with it. So just very easily, if you had a traditional traditional system like ABS, right? You had your function, you made your HARA, you had your design, and you would, of course, iterate it a little, and then you validate it, and you release the product. And of course, there are some improvements done over time, but you don't really need the safety element out of context so well, because it's a stable functionality, and you can really verify it. And sometimes it's really the carryover is heavy from previous generations and things like that. So you don't really need it. But for ADAS, we would like all the time to release new functionality, and just very high level of it. But here we have this DevOps that we have a lot of components, and we are in the DevOps getting better and better functionality. What happens if I can see farther? Does that automatically mean that I can drive faster because I can see obstacles on the road? No, not necessarily, right? So it's not linear, at least. So there is a lot of things that you need to keep in mind here when you get something that has better performance. It's not just straightforward to apply it to your system. So you need a pattern. You need a way to work with this. And this is a little where we think that the safety element of a concept can help companies. So again, I spoke a little about safety case impact upon change requirement. You can imagine if you have, I don't know how many components we should talk about, but it doesn't matter. We understand that all the hours that are needed when you are updating your function from items, from HARA, from verification and validation procedures, maybe new requirements. Let's say that you have had a function that says you're not going to go over 60 kilometers per hour. And then there is a new requirement that says, well, we would like to have this system even having the autopilot of over 105. You can immediately understand that there is a huge configuration management and CCV boards and everything that needs to be there. It's really expensive. So are there ways where you can actually avoid this? By the way, this is just to show you a little what is in the planning for ISO 262 that we see. For example, software safety management systems, for example. And this means that you really have the DevOps. How should you really be able to observe and come back and make good and fast changes to your component or your systems? Okay, again, when we speak about the ISO 262 reference lifecycle, it's really, we call it the V cycle sometimes, right? And it means that you have an activity, and when the activity has been done, it renders in a work product that has some rigor. You need to verify it, you need to review it really. And also, if you have a safety requirement, it means that you guarantee something, a failure mode basically, that this failure mode does not occur more than peep times per 1 million hours or something like that, right? So the ASIL is on the failure mode that can cause the hazardous event, that is the car to go leaving the road, not seeing an obstacle and things like that, right? And we also understand that you need to have certain argumentation why we should believe this activity has been fully carried out. Process requirements, we call it, right? Yep. So let's continue. So this is the life cycle. Here, up here, it's really where you like to set up your system, safety management systems, how you would like to update things, and how you would tailor the entire V cycle. And if we just look at the software or the system for that sake, it's here where you actually say that this is how I can do my component. But if I don't have the item definition, can I still do this? Yes, of course, that's what we do. But let's see how we can do it in a safety element out of context way. So here you also see guidelines on the ISO 262. That's where the SEooC resides. So V cycle, you have, I'm going to introduce that we have the left leg. That means that you have the product argumentation. We break down something that is really holding water, that we know that this is traceable up to the item. It's correct. Then we have the right leg. It means that we have verified it. We are testing the embedded software and things like that. So this is what I will come back to throughout the presentation here. So let's see here. The fundamental principles, I'm going to step out of ISO 262 a little and look into the layered argumentation that John Birch, he was with Myra and worked for MISRA rules and guidelines for quite some time. Very intelligent person. But he actually says that the core argumentation is that the left leg is correctly broken down and verified. The layer 1, it is really that we have integrated it. We have fulfilled the integration, that we think that now it works, right? So these are the product argumentation. We know that the product is really fulfilling the intentions. But it's not really true, right? That's why we have the layer 2 and layer 3. Layer 2 is that we have the tools. We are doing the integration according to adequate processes. If we say that code is safe, well, what do we mean? If it's good, well, have we removed all systematic faults? Well, we need to do that argumentation in layer 2. But that's not the entire truth either. So in layer 3, it means that we really need to rely on the competencies and the safety culture, that we actually do what's said, right? So we really need to rely on people doing it according to the processes and having the competencies to break down and verify. So this is one point. So the 4-layer safety argumentation means that each layer is supporting the arguments of the inside layers. So if I have a safety culture, I have competencies. Yes, that supports that I'm using good processes and tools, that I have been verifying, and that I also support that the breakdown was correct. So it's not that if you have failed something here, you can never rescue it by other layers. That's the point here. So that said, this means that safety culture argument brings value to adding confidence to the processes, that these are executed, right? And then we continue right leg verification, but in the end, left leg verification argument, the core in the safety argument, in telling why fulfilling all these requirements will make the item safe. So this is what we can now transfer to one component, for example, telling why fulfilling all these requirements will make the item fulfilling something. But if we don't have the item, we can't say that the vehicle, of course, is safe, but we can promise something similar. And going into ISO 262, many of you have probably looked into it, but there are a few concepts that are sometimes wrongly seen as safety element out of context. Sometimes you have developed a component in context of an item, which is really good. You have maybe made your software for brake functionality, and was newly developed, of course, but it doesn't mean that it can be used for another component, for another function, right? And then we have also the qualification of software. You can have something and then you say, well, can we use it? Yeah, you can qualify. It doesn't mean that it was developed as a safety element of the context, or that it was even developed as fulfilling a certain ASILs that can be qualified to see which failure modes do we have and to what integrity can we guarantee that those don't occur. And then, of course, we have the final one, that it's proven in use. It has been used so many times that here, please, you can use my component. It's a safety element out of context because it's proven in use. And that is a no, it's not. So here said, you see suitable, not suitable. This is the approach that you can choose then within the ISO 262. So we see if you would like to make a new development, well, it's suitable to use safety element out of context. Reuse, we change, safety element, it's really good to use because you can build that into your concept. And reuse without change, and of course it is. I mean, there's a component will always be doing this. You see someone not suitable at all. So if you look into the latest version of ISO 262, there are really a few areas to look out for so that you don't mistake these for safety element out of context. We don't want to spend too much time, but you here it says all the 5 concepts listed here are instead dealing with the situation when there is no full compliance to the ordinary 262 argumentation structures. So here it is. But for safety element out of context, you are fulfilling the ordinary 26262 argumentation structure for the life cycle that you are interested in. So safety element out of context again. So we would like to say that it's a component-based safety argumentation that we are looking for. And it's good to use because this is a very well-used paradigm that you can do, right? And it fits really well into the tiers structure, how they develop products, of course. And I really think that it's, if I'm just going to make a prophecy, I would say that we are going to see this happening more and more. It's not possible to maintain big, huge systems without really addressing this. That's what I believe. I can be wrong, of course. I have been before. I was wrong once when I thought I was wrong. Oh, sorry. Some terminology then to enable this safety element out of context discussion. So we need this component-based development. It's really that we would like to reuse it. And it's to enable that you break your big monolith into components. So you have a lot of assumptions. And if these assumptions are fulfilled, it means that I can guarantee something. And I can continuously see, well, this assumption is not met. Well, I shouldn't guarantee. Oh, now this assumption is met. Well, I can guarantee something. So this is what we would like to set up with the safety element out of context design. It's not just a component. It's how it should be used, how it should be integrated, how it should be developed and improved. So we can understand that it's good for the ODD expansion. If you have an ADAS that you would like to drive not in 50 kilometers per hour, rather 60. Well, what is changing then? Yeah, it would be good to do this fast, not have too much regression happening as it would be the case if you haven't thought of it before. Some thoughts, okay. We know that we can't realistically execute the entire life cycle in one sequence. That we know, we have already said that. But if we use the CBD approach, then we can make it less complex. We can make a separation of concerns. We can have these building blocks. But if they're using a certain principle, we know that some faults, failure, or errors can't propagate. So we can rely on components on the certain circumstances won't impact me badly, right? So I can verify components according to these, and I know that I can use them, and they are not shooting my my component down, for example. So continue a little. So I want to say that just because you have a component-based design, it doesn't necessarily mean that you have safety case argumentation. So the point is here that if you have a CI/CD in place, it doesn't necessarily mean that you will get a safety case argumentation just using this. So you need to really think deeper on this. There is more to say about that, but I don't want to spend too much time. But of course, if we look at the abstraction and aggregation, so aggregation means that on the vehicle level, all components here, and the abstraction is the vehicle. You can also go down, down, down until you have one component with one TSC. It's very low abstraction and it's very low aggregation. It's very simple. So you would like to see how these components are tied together in a matrix or something like that, so you know how they actually support each other. So continue. So again, if you would like to spend a few seconds here to understand assume guarantee. So we wrote actually a good paper on developing SEooC, original concept and implication when extending to ADS. So Rolf Johansson is the main author of this. So you can look that paper up. It's really good. So assume, well, if a certain timing assumption is met, we can guarantee a certain output. That's what we want, right? So if we have some VRU is detected, and we also get how sure we are about the VRU detected, it can help us if we should break. If it says, I think there is a VRU here, and we just start to break, then it would be maybe a false break, right? So we understand that it's good to have this done. And it doesn't necessarily need to be just ISO 26262. It can be used for SOTIFIsh as well, where we have a Bayesian distribution. It's how well do we perform, for example. And vertical assumption is also interesting to mention here, because you have a functional contract here. It means that if I fulfill this, I can do this, unless. So we can have something in the platform, we can have something shooting us down, and we need to put requirements and make sure that the operating system or the middleware can take care of this. And once these are done with integrity, we can guarantee it. So it means that this a safety element out of context can have assumptions also on the vertical contracts. So I would like to spend a little that when we speak about in context, out of context, of course, it's worthwhile. So of course, if we really develop something with a clear requirement from the OEMs, these are the requirements, please fulfill exactly this, and then you start, then we are in context, but it's really rare. It's usually a negotiation, right, that we need to do. But we would like to look into also the locally in context or out of context. If we are locally in context, it means that we have actually the previous input or the life cycles that should have been done. If they are done, we can say that we are locally in context, that we have received perfect requirement that we can match to. We can say that we are locally in context because we have the real input to play around with. But if there is at least one SEooC in the trace up to related safety code, then we can't be. We can at the same time be both locally in context but globally out of context, because we don't have a full trace to the safety goals. So it's important to actually understand that and continue. If at least one assumed input is absent when starting the life cycle of a certain activity, we will be developed locally out of context. So it means that we have some knowledge about this system, but we are locally out of context. So we need to take care of this by having some assumptions. We need to say that, well, if it's like this big, or if the speed can vary like this, we can handle it. If it's going to vary like this, well, we need to sort of lower the expectations on our components. Of course, safety contract has been around for quite some time. Okay, so what we like to say there and state here, there is really no difference between doing in context and out of context development. And like I said here, in both cases, we shall have a full set of inputs where the applicable safety requirements are found. It is never a question of just following some safety process or ASIL capability, because I've seen that quite a lot. I was an assessor for some time, that they thought that, well, here we've used these coding guidelines, we use this, blah, 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 blah. And of course, it's methodologies that are plus or whatever. So to some extent, yes, but if you have a safety element that you need to really follow these according to your safety plan, right? So process arguments are always a second supporting layer. They are dependent on the specific core and specific first layer. That is breakdown of requirements and the verification. So process, yes, it's good, but you can't say that we are fulfilling some ASIL with our software without really knowing which assume requirements or how they should be verified, the verification plan, the integration plan. So a little about that. You will see more in the, I see that the time is running for me. But again, so integration of a safety element of the context, it means really that we need to fulfill all the layers. And it's really bi-directional check here, as a safety contract contains safety requirements both in the role of assume and guarantee. So we need to be sure that we have fulfilled, we can detect faults coming in, or that we make sure that we have a requirement on those sending that, so we can forget about that, so to speak. So again, just summarizing before we are going to look into one example. So a safety element of safety element out of context can be a system, subsystem, a combination of systems, a software component, a hardware component, a part. We know for sure that the ECUs are sometimes coming as a safety element of context, but then what does it mean? And I know that I had a quite extensive or deep discussions with some of the ECU manufacturers when we did the safety element of the context, and I got some really good feedback that we should be looking at. But AUTOSAR safety software stack is something really close to what we say is a safety element of context. But again, what I will focus here is really on the software. So let's continue. So let's say that we have a system, semi-system, ADAS, let's call it an ADAS system. We remember the safety element out of context can never be an item, and it will always have to be integrated to some extent. So we can look here, sensor is a safety element of context, perception, driving policy, or how we should path plan. And the actuators also can be a safety element there. But then the integration needs to be done in order to fulfill, for example, the AEB, the item, for example, on the vehicle level. So that's really what we need to say. So how should we come up with the safety case here? Yeah, that is the question, and we can come back to that. So if we look at the safety element out of context on a technical concept level, it means that, for this is from the standard, by the way. But if you look here, we have broken down, the OEM has a lot of technical safety concepts. And now let's say that this is a subsystem or a system A with 1, 2, or 1, 2, 3 components, or module, or ECUs, or just software components or functions. You have distributed some requirements here, technical safety concept, and you have distributed and already got okay. And then you say, there is something missing there. And you really hope that if it's a brake or if it's a camera, whatever, that these persons, they will actually have something that fits really well into here. They have already thought of meeting these technical safety concepts. They already have thought of meeting these technical safety concepts. And for sure, in these hardware software integration testing, it will be done. So we understand that it's something that will be easily integrated into your requirements breakdown in the end. So we can continue. And if you look at this system again, so this is from the standard again that we wrote some, wow, it's so many years ago. But if you have the concept piece, this is software component development. You have done so much assumptions. You are, for example, delivering a LiDAR. You are considering quite a lot in your system, your subsystems, and you are really looking into software safety element out of context development. And it means that you have assumed something on the system level. And this is where you actually want to, in the end, establish or validate these assumptions. This is the point that the OEM, the integrator, needs to do, right? But in doing this, assumptions on the system levels, we of course have this software development life cycle. And here you can actually see which parts of the standard that you need to fulfill, and that means that you need to tailor it. So here you consider fully in the scope of software safety element or context and things like that. So these are chapters, and it comes from everything from software safety requirements to actually the integration of it. And you can look here. So the first is general topic for the product development at the software level. Of course, you need to really use these fully. Specification of software safety requirement. There is not a single clause that you don't need to do. They are fully. But the software architectural design, maybe you don't really need to fulfill everything there. It depends, but you tailor it, and you have done your argumentation. You have a SWOT. You have also software unit design and implementation to some extent, but you can't do all the clauses that are said in the standard, for example. And this is how it continues. So of course, for your safety element of context, you have something called like your software development plan. So again, how would it look like? Well, you have your assumed technical safety concept things here, and you would like to make sure that you specify your component here according to these assumptions. And in the end, it should be fairly easy to integrate this with the OEM's expected and show that you have really fulfilled the expectations. So again, speeding up a little, but it's the same here. What could it be then? Assumption of software design. So the software component is integrated a given software layered architecture. That could be an assumption, and the potential interference caused by the software component is detected and should be handled by its environment, like a vertical contract, so things like that. The software component provides the functions specified in the assumed software functional requirements and things like that. But we can take it even deeper. So assumption on a higher level, it could be that the resulting software safety requirements allocated to my safety element out of context could be these requirements. The software detects any corruption on the input data which can violate safety goal, blah, 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 or similar things like that. But this is not the whole truth of a safety element out of context. It's so much more. It's, of course, to do it in SEooC, and you are going to provide support for certain concepts that are distributed in your system. So this said, we need to have these assumptions explicitly stated. That is important. Which ASIL, I mean, which integrity we can actually do it with. The time I will take an example. This is, you can read it in the slides. But if we look at one real example in the ADAS now, we can just take an ideal safety principle: don't drive faster than you should. So this is something that maybe an OEM would say that we would like to have a system that drives safely. We have this as safety goal: don't drive over your capability, drive safely. And of course, if you look at this picture, you would like to see something happening. Oh, there I see the pedestrian, right? And there actually the computer takes it. Okay, so we understand that, of course, there is a SEooC process to this. And we also understand that it's Bayesian statistics here. But if we actually look into this situation, how fast should you drive according to this? What should you do? How should you do it? Should you drive fast here? No, people would slow down because it's hard to actually see with a camera when it's rainy and gloomy outside. So why I say this? Well, a component can have certain limitations, and we need to know them. So let's continue. So some principle for the safety element out of context component could be these 4 principles. So of course, a safety element out of context should continuously establish and communicate the confidence of the data that the component delivers, runtime in runtime. It means that runtime requirements taking care of when things are changed also. They don't look the same. If I'm going in 90 kilometers, I don't have the same requirement as if I was driving in 70 kilometers. So these are typical concepts that you can introduce into your safety element out of context, that we would like to state how good are we at the same, because that will be useful when you build a system. And also your safety element out of context should ensure and maintain a verified statistical performance or data sheets for different profiles. For example, a radar could be this good in snow, this good in perfect light without rain and things like that. Or, I mean, you can come up with the various profiles for various components, of course. But in the end, we want to know how it behaves. And then you have the few designs so that tactical decisions can be executed that allow you to stay within operational capability. So here, for example, if something is changed, you are lowering the speed. So you can have design requirements already done that will take care of the safety element out of context data. So you adapt yourself. And also, of course, in the DevOps, we would like to have triggering conditions so that we feel feedback data from the field so that you understand that, oh, my camera is, it's about to be better and better. So if you have a good concept there, you can improve your camera or your radar according to this. And if you have the assumptions done, it should be easier also to know the impact on the item. Not to say too much on runtime design, you will have it in the slides. But just to take how it could look like. So this is something built up then on several safety elements that are context, and in the end they are integrated into some ADAS functionality. And we can say that if we look at the perception, you can have your safety element out of I would like to spend really my time on confidence is high, but view of surroundings wrong. I don't want to be arrogant. I don't want to be overconfident. So I can actually know in my design what do I need in order not to be arrogant, because we know that being blind, if I know it's not so bad, right? But if I think I see and I'm blind, that's really bad. So there is assume guarantee thinking here. Observations, they come with confidence, and that means that I can also report surroundings like predictions. Where is a VRU? Where am I sure that the VRU is? And I can provide the confidence. And assume guarantee, the same here. Assume that if you give me this with this confidence, I can guarantee these plans. So we can continue going through this entire, and this is just one example of it, and you can come up with others. But I think that ADAS is really a very good area where you can really take the safety element out into extreme context into extreme. So short summary, you really need to apply a full safety life cycle. You need to have your assumptions verified. You need to show this process argumentation. And when you have that done, according to design, it is much likely that you can also fit into a system. It's like a pattern. So here, by assuring the core safety argumentation this way, every update of the main branch can guarantee that the safety case fragments of each safety element up together always can build a complete safety case. So that is the thing. So we think that a component can have a safety case fragment, and all these fragments together build the real safety case. And we think that, again, looking into the core and all these layers, right? The CI have two different tasks. The first is to check the existence for each of the core for each of the safety element context, and the second is to produce these core argumentation. But that is to make the integration done. And in that, oh my, the time is flying here. Sorry for that. But again, summary: safety element of context is really a pattern. And if you design, if you have if you're an OEM or if you have a item, if I may say so, you can, by doing these patterns, safety tactics, you can have this as a clear assumptions known for those that will come with the components, right? And it's really well suited to form the base for automatically generate complete safety cases. I don't think you can do it without using safety element out of context. And then I have, of course, some final remarks, but you will see them as well in the presentation. I'm so sorry that I had to stress. I should have known, but without coming too much, I think that if you are having an architecture, if you focus your time on building good architecture that are scalable and expandable, fulfilling fundamental design principles, it can actually allow good SEooC patterns and a good DevOps. And you also need to be, sometimes you think that you don't need to take safety expertise into account maybe when you're setting something up. ABS, for example, it's like you have a very good function, and then please implement it safely. What I mean here is that safety engineering will become a really integral part of doing the product. ABS, it was, okay, please don't let any systematic faults happening here. Don't let any random hardware faults happen more than this often so that we lose our ABS, for example. But now it's safety is needed to be a more integral part of it. So that's pretty much it. And I thank you very much for listening, and I hope to receive some questions. And again, you are welcome also to contact me on my email here. So thank you very much.
Yeah, thank you, Håkan. I do see there's a question on chat. Somebody asked, can an OS middleware be seen as a safety element out of context?
Yes.
Okay.
Maybe some would, I mean, it depends, of course, but you can design it as a safety element out of context.
Pietro, I also allow you to talk. So if you want to.
See an old friend.
Can you
Hello.
hear me?
Yes, I hear you.
Hi, I
Pietro.
Yeah, I mean, with my company, we're developing an OS, so we are planning for developing it as a safety element of the context, but I'm not so into the ISO 26262. So in your slides, I have seen that you mentioned only some functional parts like cameras or application level stuff. And I was wondering if safety OS can be also developed as a safety element of the context. Which are the criticalities of doing that compared to an application level or safety element of the context?
It was a little scrapey. I couldn't really hear everything really well, but I think.
Oh, sorry.
But what I think am I answering is that depending on which applications you're aiming for and which aggregation level and which abstraction, you would try to solve a little different tasks. So I mean, and also software and system and hardware would look different as well. But it's always, I think, possible to apply the safety element out of context principle. I know that we need to update the standard a little. And I think I see that Christopher Temple is here as well. He actually proposed me to do some changes, especially with in the light of microcontrollers, for example. But I think if you're a component provider, it should be possible to fairly easy come up with these assumptions and design according to that.
Thank you, Håkan.
Håkan, there are a couple questions on the Q&A panel. Can you see them, or I can read them out too?
Yeah, I will see here now. Okay, thank you. If we are developing ABS as an SEO, is the logic of ABS out of safety scope? I would say the logic of the ABS is not out of safety scope. It is not, but it's what we say is that you have designed your system that you say what is in scope. So depending on your scope, it will be used differently, I would expect. But the logic definitely could be a safety element out of context as well.
Okay, and there's a question on our Q&A window. Should we consider ML ops of ADAS system instead of DevOps?
I think that what we have are looking at, and many others, of course. I mean, what we looking at to AI, I mean, there are some standards coming up, 8800, and there are others as well. I think that when you describe your AI and when you have, this is a process to reach some results. I mean, the principle can still be used. It's just that maybe you won't get like this failure mode can reach an integrity of 10 to the -7 or 8 or something like that. But sometimes AI can be good enough even with lower. I mean, you guarantee something, or you actually, this is what we will provide. This is how it looks like if you give me this. So I mean, the principle can be used for AI for sure.
Great. And there's another question: who defines acceptable failure rates?
To begin with, I mean, it would be you to say that what can I achieve? But maybe you would like to stress yourself. I mean, if you look at the competitors, you say that, well, my piece of hardware should only have these failure modes to this rate. We can press ourselves for. We actually implement ECC here, then we will be better than our competitors. But then it's up to you how you fit into the architecture of the integrator, right? If it's needed. But sometimes, oh, you're fulfilling this. We don't need that additional redundancy. Oh, great. We don't need that. So it depends.
There's another question. When we follow the certain SO requirement from ISO 26262, should we really strict to plus requirements for the specific SO, or it depends on the certain situation?
Can you read it again, please?
When we follow the certain ISO requirement from ISO 26262, should we really strict to plus requirements for the specific?
Okay, yeah, good. Now I understand.
Situation.
I mean, it's again about what you'd like to sell. When I was working for McKell, we definitely said that, okay, for ASIL-B, we have a test plan, we have the strategy, we had the failure modes, we knew we had an Infinium processor that we are going to use, and blah, blah, blah. And then we said, we need to do this and this and this and this and that. So we used that. So it's up to I mean, in the standard, it actually opens up that you can sometimes choose methodology. It's up to you to argue. You can say that we use this tool and this tool or this methodology, but not that. But sometimes you need to somehow argue that even if it's just recommended, you need to argue why you're not using it. So it depends on what argumentation you would like to give in the end and what it should be used for. So it might be that they say, well, we don't really think that you have a safety case for this software when you haven't done plus plus.
Okay, this question, if we develop a TSC, I assume you mean technical steering
Technical
committee?
safety concept. Technical safety concept.
Oh,
Yeah.
okay. Document as safety element out of context. Are there any additional activities or considerations compared to the normal TSC development procedure?
Yeah, even here it might be that I mean, if you have control over the execution environment, it's one thing, but there are quite a few requirements in the standard. For example, coexistence. It's like freedom from interference, and sometimes it means that you need, in order to have my TSC working perfectly, I need this interface. So you need, of course, to negotiate. And there are some dependencies that you need to look into. For example, if you say that it should be a decomposition, I mean, in the standard it says that you can decompose an ASIL-D into two ASIL-B, and that's when it comes to the process argumentation. But if you look at the hardware that it consists of, you need to fulfill some budget. So you may need to go into something that we call the fit rates or the latent point fault matrix, single point fault matrix. So you need to really see how big a share you take of the top level failure rate, so to speak. That's what you need to look into, if you understand what I mean. It's not always so easy. There is sometimes fault trees where you need to be quantitative. You need to say that we take care of these failure modes and you take care of that, and together we need to ensure 10 to the minus 8 faults per hour on this failure mode.
Okay, there's one last question. If some assumptions were used for the item development, can, in this case, this item be considered as safety element out of context?
If you have an item, you don't have a safety element out of context. But the second you say that I don't have the specific vehicle, we have discussed that in the ISO 262 some 15 years ago as well. So I think it's a good question. I mean, there might be some, for example, if you have one OEM has, you know, a platform, but they have like 5 different models. They are different items. Maybe they have the camera positioned on different heights, and also the pitch of the car when it brakes will look different, etc., etc. So you need to have some configurability of your sort of your system. And this is, I think it's important, because then you need to do an impact analysis. What does this mean that I move it to these circumstance, this specifics of that car? So you need to make an impact analysis, and then you can have an item again.
Great. And that's all the questions we got, and we're at time. I just want to say thank you again, Håkan, for giving us this really informative talk, and for everybody who joined us for the hour. And we'll get the recording and slides distributed to those who registered. And thank you again. And please do go to elisa.tech website and sign up for any upcoming events we have in the coming days. So thank you again. And Kate, do you want to say anything else?
I just want to say thank you again to Håkan for doing this.
Thank you, Kate.
We
Nice
challenged
seeing
you
you
at
again.
the workshop. But very useful
Yeah.
to the community. Much appreciated.
Yeah. Take care.
Take care.
Bye, everybody.
Bye. Thank you, Chris.